So here I have made some slides to mention about what you should be looking for when you prepare for your undergraduate physics report. So basically a report should comprise of all these sections that is displayed on the screen. So you should have a, say, introduction, and then you should have some part called project introductions, literature review, theory, methodology, result and discussion, conclusion, suggestion for future works, reference, and appendix. So this would be the major topic or chapters that should appear in your report. I don't call this a thesis, but I'll call it a report instead. Okay, it's not really a thesis. So for your references, I have tried to create, try to provide two links to two of the final year project report that I think are well written from those previous seniors of yours. So you can try to click a link on this, then you'll be led to some of the project report that was produced by them. Two of them, one of them is Ming Yang, and then the other person is by Yong Sing. So both of them has already graduated long time ago. I think they're still alive. Both are very, very smart students. So their report seems to be well written, even though it's not perfect, but it gives you some idea of what a good report should look like. Okay. So you can make use of these two reports as a reference for yourself when you prepare for the thesis. So for the report, usually USM requires some kind of format. So here I'm not going to talk about the exact format like the margin, the font to use, how many spacing. So I'm not going to talk about all these minor detail, but I'm going to talk about the content of the report, which is more important. Usually in a report or in a thesis, you have the first thing called the front matter. So the front matter are referring to the matter that is the preliminary sections of document. It includes the pages starting from the title page up to those pages before the major content. Say for example, in this example of the report, so this is the title page. It's part of the front matter. So you have acknowledgement, you have abstract in English, in Bahasa, and then you have these tables of content, list of content, list of table. So all these pages until page 10 in Roman are what we call the front matter. So you start to count the page from page 1 only when you enter the proper chapter 1. Okay, so this is chapter 1, and before the chapter 1, you label only the page with the Roman character from 1 to 1, 2, 3, 4, 5 in the Roman form. Okay, these are called the front matter. So in a report, you have front matter, then you have chapter 1, chapter 2, chapter 3, chapter 4. Each of the chapter that you see here would then be further broken down into other sub-chapter. So this is the chapter, and then this background is considered as one of the subsection in the chapter. So usually I'll call the chapter as a section, then the smaller chapter in a chapter, the sub-chapter, I will call it a subsection, right? So for example, in the chapter 1 introduction, you would have a subsections of the background, problem statements, objective, and scope, and also the novelty of research gap, but this is optional. Then you have also a subsection on outline. Then usually in the thesis or in the report, you have the second chapter, which is about the theory. Then you have chapter 3, where you talk about the literature review. Then you have chapter 4, which usually is a chapter for methodology. And then chapter 5, you would present your results and discussions. Whereas in the chapter 6 is the conclusion and future work. So these are the general sort of like topics or chapters or sections in a report. It is not strictly need to be strictly followed, but you can just follow this for the sake of simplicity. Unless you're different, then only your sections will be different than the one that I show here. Okay, so usually first chapter will be introduction, second chapter with theory, third chapter literature review. Sometimes literature review and the theory will interchange. You report literature review first before you report the theory. Then usually you have to have a chapter on methodology, chapter on result discussions. After you have finished your conclusion, and then you will have to include a sort of like an section where you have to show all your references, and then usually you have an appendix, but appendix is optional. Sometimes you don't have an appendix, sometimes you do. Okay, so this is a general sections in a project report. So what I'm going to do next is to talk about what goes into chapter 1. Now in chapter 1, which usually we label the title of chapter 1 as introduction. So usually these are the items or subsection that should goes into chapter 1. It includes overview of the project or a background. So you have to provide a background of your project. Say something general about the project so that people have some idea, very broad idea what your project is about. Then your report have also need to talk about what is the problem statements, the objective, the scope of your project, your novelty or the research gap. But sometimes for undergraduate course, you may have no novelty or research gap. Maybe sometimes your supervisor just asks you to reproduce some existing result from the paper or from textbook. So there will be no novelty involved. So in that case, maybe you would not need to talk about the novelty. And then usually you have an outline sections, outline subsection that helps people the structure of the thesis. Say you have first chapter is about what, second chapter is about what, third chapter is about what. So the outline here, the outline subsection is relatively not so important. So I have tried to include some of the example that I could find from the previous thesis, the example of how to write an example of a background for your project. Then this is example of a problem statements, example of objective, example of the scope, and the example of novelty, another example of the research gap. So these are just to serve as an example so that you can have an idea what are you going to write in this subsection. In the subsection of example of background, you usually have to provide an overall view of what project are you doing. For example, in this case, it is a project that is written by Ming Yang that tries to do a simulations, a molecular dynamic simulation. So he talked about something general about molecular dynamic simulations, and also the general features of molecular dynamics. So this would be just a general introduction, but you can actually go beyond the background. You can talk a little bit more about the background of the project instead of just touching it on the surface. So there's no strict rule to say what you should write in your background, as long as you provide some general idea of the topic you are doing. Then this is the problem statements. The problem statements to me, when I look at the problem statement in the beginning, before I am familiar with how to write problem statements, usually it's very confusing statements. But the problem statements actually is a paragraph or sentences that mention what is the problem. Here you don't talk about the solution, but you talk about the problem. So for example here, this is an example of a problem statement that I take from the other project on reinforcement learning. So this is a physics project that was trying to solve what we call a tiling problem in mathematics. And solving a tiling problem in mathematics is very, very difficult because of the mathematical complications in the structures of the mathematical problem. It's a heavy hard problem, and if you want to solve this problem for a general case, it is always very difficult because of all this different complexity. So this complexity makes the project difficult to calculate. Therefore, the problem statement is an explanation about the difficulty that is happening inside this kind of tiling problem. So another example would be, say, for example, you want to solve an black hole problem, and then there would be an problem statements about the problem you want to solve. For example, the problem would be extremely hard, and then no one knows what the exact solution is. People only know the approximate solutions. So this is a problem that is facing the problem that you are trying to solve. So then you have to make the statements about the difficulty in the project. Okay, so this is just an example of a problem statements. So usually you don't really need to address what is a solution to the problem statements, but what is more important is to address the problem that is facing the project you want to solve. In this case, the problem of a tiling problem is really a mathematical difficult problem, and you cannot solve it easily without using other complicated method. Especially if you are to solve this tiling problem using conventional algorithm, then you will have a problem because you may not be able to solve it within your polynomial time, which is mean that time that is short enough for you to still alive. Okay, so you may take such as the length of the whole universe, the age of the universe before you can solve the problem. Okay, so I hope that you understand now what it meant by a problem statements. So you usually have to state these problem statements in your report. Now, another very important content that should be reported in your report is about objective. Now, objective usually comes in the forms of a statements. Okay, so here there you have one statement, then you have another statement. So 1 and 2. So instead of writing down a long paragraph, usually you just list down the first objective and second objective. It must be something that is very tangible and something that will be solved at the end of your project. Usually you don't want to write, say, 5 objectives or 10 objectives. Usually you just compactly mention 1 or 2. Maybe 1 is enough, but sometimes it is not enough. Then you have to provide 2 or 3. So each of these statements of objective are the objective that you want to achieve at the end of your project. So this is an example of an objective statement that is to simulate a wetting phenomena using some deep tree water droplets on a substrate using molecular dynamics. So at the end of the project, this person who defined this objective will come up with an molecular dynamic simulations that is simulating the wetting of a nanodroplet on a copper substrate. And then the second object in this example is that at the end of the project, he will be able to measure the contact angles from the molecular dynamic simulations. So he'll be able to report the values of the wetting angle measured from the simulation. Okay, so this would be 2 objective questions that is trying to solve. Now, these are very important questions. When you design your objective, you have to think about this. At the end of your project, you would have finished all your calculations, and the result of the calculation must answer the 2 objectives or 3 objectives that you mentioned in the beginning. You cannot mention some objective in the beginning, but at the end of the project, the solutions that you obtain from the results does not address the objective. Say, for example, you say your objective is to say calculate the strength of some metal. By the end of the project, if you do not report any result of the strength of the metal that you mentioned in the objective, that means your objective has failed. So you must only mention the objective that you have achieved at the end of your project, right? So you don't want to have too many objectives so that it makes your reporting very, very difficult. So with the objective, then your research will be very focused and you will not be diffused into many directions until you get confused along the way. Okay, so these are the objectives that should be mentioned in your report. Then also you have to mention about the scope. The scope is the limit of your project. Like you do not want to calculate all those stuff that is very general. For example, if you are calculating some problem in 2 dimensions and you're not calculating the problem in 3 dimensions, then you have to specify that your scope is to calculate this problem in 2D and you're not going to touch anything on 3D. Say, for example, here, this is a scope that mentioned that they are going to use a software approach to perform molecular dynamic simulations at 33 degree K for Lennard-Jones droplets that remains in the liquid state, and also a substrate that is made up of a cuprum atom. So in other words, that it says here, he's not going to calculate and molecular dynamics of other droplets other than Lennard-Jones, and his calculation would only happen at the 83 degree. He's not going to address the calculation at, say, 70 degree K or 120 degree K. And his project also do not calculate the simulations on the substrate which is made up of other than cuprum. So only cuprum substrate will be simulated in his simulation. And then the configuration is only on the inner curved surface of the solid cylindrical, but not on some other type of geometry which is not curved. Okay, so you need to provide a scope in your first chapter in your introduction, so that you limit the scope of your calculations, and that also helps to protect you people, because if you don't specify your scope correctly, then people would think that your calculation would involve some other domain which is larger than what you are calculating. Say, for example, you are calculating only atoms of up to, say, 100. If you don't specify that I'm only calculating atoms of up to 100, then people would thought that you are calculating up to arbitrary large numbers of atoms, right? So you always have to understand where is the scope of the project, then you specify specifically in this part of your scope. Okay, so then if you have a novelty in your project, then you just specify it. For example, you said that no, people have not used the reinforcement learning to solve the tiling problem. I'm the first person to use reinforcement learning to solve the tiling problem. So therefore, this project is novel because this is the first time people use this method. Before that, people use other method, but not reinforcement learning. So this will consider as a novel method because no one have done it before using this method. Sometimes you also want to mention the research gap. For example, people only do a simulation only for 2D Lennard-Jones droplet simulation, or do 3D simulation or 2D simulation, but they never compare both 2D and 3D. Therefore, in this project, this guy who write this research gap, he says that I'm going to simulate both 2D droplet and 3D droplet and compare them. And this is something that has not been done in the literature. So that is the research gap I'm going to fill up. So if you have a research gap in your project, then you should mention that. So this is an example of a research gap. An outline is just a very simple description of what are the content that will go in chapter 1, chapter 2, chapter 3, chapter 4, chapter 5, chapter 6. So this is considered most easy subsection to write in the whole report. Now, up to this point, I will pause for a while to see if anyone want to ask any questions before I proceed on. Okay, so if there's no question, then I'll continue. So the rest of this, so what I have done here is I've explained to you what should be happening or what should be mentioned in the first chapter. The first chapter would include all those things that I mentioned. Here, it should have project background, problem statements, objectives, scope, novelty, and also outline. But at the end, when people finish reading your first chapter, these are the product people should get when they finish reading your first chapter, right? So people who read your first chapter should understand what are the problems that you try to address and the motivations of your problem and the background of your problem and the specific objective that you want to accomplish, the methodology. Sorry, I think the methodology is not in because the first chapter has no methodology yet. So this is not going to go into here, so I'm sorry. Then people will also sort of like have some idea of what are the anticipated outcomes and the significance or potential finding the project aims to contribute at the field. So at least you will have to mention all this in your first chapter. So you yeah. So these are the what we call the outcome when people finish reading your chapter 1. Now you see, when you write a project report, you always want to think in this way. That is, every time you have to think, I want to write something in my report so that people can understand. And you have to make this as your priority when you write your thesis report or your project report. You don't want to write something that after people reading your report, people don't understand what are you doing. Like people who finish reading your first chapter, if you cannot answer all these questions, that means your report or at least your first chapter is not written properly, right? So we always think of the results from the beginning. That is, when you write your introduction chapter, you hope that at the end of your introduction chapter, your readers will be able to understand all these following key aspects. Okay. Now this is just a slide to tell you. Sometimes people, after you finish writing your first chapter, will you write another chapter in the second chapter as a theory chapter or the literature review chapter? So it turns out that there is no fixed rule. Some people write the theoretical chapter after the first chapter, and some people write literature review. So sometimes people use an integrated approach where they combine both theory chapter and the literature review chapter in one. So I myself do not, I'm not very particular about which one should come in first. I don't really mind if you have an integrated approach where you combine the literature review and the theory. But the problem is that in USM, sometimes people are just very specific, or I would say rigid, where they say you must follow this method. You must follow chapter 1, introduction. Second, it must be literature review. Theory must come in the third chapter. You cannot combine both in one chapter, blah, blah, blah. But to me, these are just formality, right? It's just just a format, which is not really the important thing in a report. To me, what is most important in the report is that you report correctly your findings and people understands what you have achieved. Okay, so the format is not really the most important thing. To some people, it is the most important, but to me, it is not. The content is more important than the format. Okay. Okay. So anyway, after this, then you go to the next part, the theory chapter. So I assume that after you have finished the first chapter, you have to write a chapter to explain about the theory. So most people who are attending this online session are those project students who are taking project that is theoretical or computational. So the rest of the few slides are just some advice what should be going in your theory chapter. So these are all things you can read from the slides. So make sure that the chapter provide an comprehensive foundation for your project, and then aim for its sufficiency rather than excessive detail. Focus on clarity and relevance. Now, what these slides try to tell you is that according to the previous experience, most people, many people, maybe like 90% of people, when they come to write down their theory for their project, they tend to just squeeze in everything. Details one, not details one, relevant one, not relevant one. They can't distinguish, so they simply put everything in. So that is what you try to avoid, right? Because you may slot in too much rubbish that is not relevant to your project. So you should try to avoid that. You should try to only provide the most sufficient and essential theoretical detail, but not too much detail, or those that is not directly relevant. People also tempted to cut and paste from the literature review. Try not to do that, okay? Try to understand the content of the literature review, of the theory that you have learned, and synthesize it, write and narrate it using your own understandings. I think in the before 2023, people can't do that. I think before 2022, people find it very difficult to write their own sentence. Therefore, people cut and paste. But after 2020 or 2023, with the invention of ChatGPT, this will not be any more problem. Right? You can just use ChatGPT to rephrase or to summarize all the theories, all the wordings uniquely into your thesis. Okay, so but you try to understand what you do using ChatGPT instead of just passively ask ChatGPT to rephrase the theory. If you yourself don't understand the theory, then you cannot distinguish whether ChatGPT has expressed the theory correctly or not. Okay, so you have to know the theory before you ask ChatGPT to do it for you. Okay, so again, rephrasing is a must. Last time people, sometimes people just don't care, but now you don't really need to do this yourself. ChatGPT can always do the rephrasing for you easily. Okay, so use ChatGPT to do that. It's fine to do it correctly. Okay. Now, sometimes people would tend to write down theory that are too much. They say, for example, some people would like to say, for example, superstring theory have solved all our problem. So this is a wrong statement. So when you write the theoretical theory for your content, try not to make over statements. Try not to make unnecessary exaggeration. Now, I have to include these slides here because sometimes in the past, I found people do that. They just find, wow, this statement is very great. They want to exaggerate very much their project. So they would talk big about the importance or significance of the project they are doing. So whenever they see some exaggerating statements, they just slot it in. So I would advise that when you prepare your theoretical statements, try to maintain a balance and measure tone in your explanation. So try to avoid overblowing. Now, this is another thing. When you write the theoretical part in your project, you always tend to cut and paste whatever thing that is given to you without understanding it. And that is something which is very dangerous because you would be asked during the Viva, what are you writing? You make these statements, like for example, some formula, some divergence dot V equals to 3K or whatever, and you will get requested to explain during the Viva. So you try not to cut and paste all the statements or theoretical statements that you don't understand. Try to only produce those statements that you can understand in your theory. If you need to put in theory that you yourself do not really understand them, try to understand them first before you put these statements into your writing. I like to do that. When I see people writing exaggerating statements, very complicated formula, this and that in the project, then you just ask them, what is this? They can't even explain the definition of the symbol, right? So you make yourself very embarrassed by just simply cut and paste unfamiliar statements in your theory. Okay, so I'm just going to skip this. I'm going to skip this. So the next thing is a literature review. Now, when you do literature review, you try not to simply put every literature review that you read and summarize it in your project, because not all reviews are directly relevant. Some review or some work are just not related. So when you write your literature review and people read it, then people would sort of like understand how well you understand your problem. Now, if you understand very well what you are doing, you would only include those review or work that is relevant. If you do not know what people are doing, you do not know what you are doing, and you simply just review everything that people have done using ChatGPT into your project, then those who understands both would know that you know nothing, because you just simply slot in rubbish that is not related to your project and you think it's related. Right? So showing your ignorance in this way expose your weakness to the potential reviewer. Okay. The reviewer here, I mean the examiner. Okay, so try to avoid excessive irrelevant literature. I always find these things happen in the past because people just see literature review. For example, when we see molecular dynamics, then they put all molecular dynamics literature review into the project. But molecular dynamic review in our project is only, say, on small molecules, water or cluster. But the people include those molecular dynamics for, say, DNA, molecular dynamics for macromolecules in biology. So that is relevant. That is not relevant at all. People still put it in. So if you do that, then people know that you don't really know what is molecular dynamics well, because this kind of molecular dynamics is not the kind of molecular dynamics that is that we do in physics or material science. Okay, so those molecular dynamics on biological system and those in material science are quite different. So you don't mix them up. If you mix them up in your literature review, you are reviewing your ignorance on it. Okay. Okay, let me try to do speed up my calculations. So again, people love to cut and paste. So try to resist the cut and paste of the literature review, especially in this era where ChatGPT is rampant. Anyway, it's very, very easy to do literature review. You just find out some, say, 10 paper, you read it up, then if you don't read it up, then you thought that literature review is relevant. Then you ask GPT to summarize this paper for me. Then, of course, ChatGPT will summarize it within like a few seconds. But if you do not read the literature review carefully, then you may summarize those that is totally unrelated, right? So try not to do that. So again, these are very similar to the previous slides on the theoretical part. You can always rephrase the literature review using your own language, using ChatGPT. Okay. Okay, so usually the literature review and the theoretical part are kind of like not as difficult, because you can usually prepare these two chapters based on known information. Say you have based on the textbook or the articles written by others. You just rephrase it and put it together. But the methodology sometimes are not as simple. For example, the methodology in my project are slightly different than the others, because we have to invent our own methodology sometimes the methodology is very complicated. It involves many steps, and you cannot find out how to write this methodology in the literature. So you have to write the methodology yourself, at least in my project. Okay, so the methodology chapter requires you to do this, right? So you have to clearly outline the theoretical framework guiding your project. You have to describe systematic steps taken to develop your model, and then you have to emphasize the logical progression of your methodology. So this is mainly meant for those projects that is theoretical based. For example, those those projects offered by Dr. Low and those projects by Dr. Husni. So these are theoretical project. So when you describe the method, you have to explain it in a logical manner. You have to calculate first A, then calculate B, then calculate C, calculate D. You cannot reverse the order. If you reverse the order, then people get confused because, for example, you may have to calculate B first before you can calculate C. But if you don't explain your methodology correctly, then you say, oh, I'll calculate C first, then only I'll calculate B. Then people know that your methodology is wrong. I think so. To me, based on my experience, explaining methodology is actually very challenging because you are trying to explain a very complicated scientific procedure step by step, systematically following a logical flow, using jargons and using very precise language. And usually you don't have to do this in your daily life, but for your project, you have to do this. So writing a theoretical methodology section sometimes could be quite confusing and difficult, and it's very challenging. But anyway, this is just a general guideline that tells you how you should write your methodology. For those projects that involve computational procedure, then you have to explain your algorithm and how you implement the algorithm and how you do your calculation, step 1, step 2, step 3, step 4. And usually for some of the computational procedure, you would be using numerical methods, such as, for example, Dr. Su's project on astronomy. So they would deploy program using TensorFlow, machine learning packages and things like that. So you have to mention the packages you use and also have to explain the rationale why you choose these packages. Okay, so then you have to highlight the key computational tools and the resource used during the project. So these are quite straightforward to explain what are the tools, but the process of describing the computational procedure have to be explained clearly, step by steps. And when you write down your procedure in your methodology, you have to bear in mind that whatever you write down, the purpose is for the reader to read it and be able to follow your procedure and reproduce the result as you have reported. So you would want to make your report writing for the procedure and methodology to be as transparent as possible. You don't want to hide something that you know is wrong, but you don't dare to report it. But even though it is wrong and it gives you some result which is not as good, you still have to report it. You still have to report it so that people know that there are something that is working, there are something that is not working. Okay, so for example, when you do a machine learning simulation, you train the machine learning, then you ask it to produce some number. And if you find that using this method, some number are produced correctly, some number are not producing correctly, then you have to explain this. You have to say that this is the method I use, and sometimes this method gives me the correct number, but in other times, occasionally it does not give me the correct number. So you have to make sure that this transparency is included in the description of a methodology, so that when people reproduce your method, reproduce your result, and they also discover the same problem, then they know that this is expected. Okay, so sometimes your methodology will be very lengthy. For example, you may have a lot of codes. Then sometimes you may have to sort of like put these codes, very complicated codes, like whole stack of these codes, hundreds of pages in some supplementary materials or in code repository. Okay, the most important thing in the methodology section is this. Again, I mentioned this earlier, that is people who read your descriptions of the methodology should be able to produce your result. Now, if your methodology is written in such a way that people who follow very, very diligently cannot understand what you are doing, cannot know or cannot reproduce your calculation steps, then your methodology section is considered not written properly. Okay, so that is always what I say. It's a strategy that is what I call think from an end. You want to write something so that at the end people understands you and able to reproduce your writing, reproduce your result. If people who follow your writing cannot reproduce it due to this reason or that reason, measure the energy of this method, of this energy of this system to be like 1.2 EV. Then you have to discuss how you can justify that this number is a expected and a correct number. So you have to mention that. I always ask this question during the Viva. You have obtained this result from your theoretical calculation or from your computer simulations. Then can you assure me that this number is correct? So you have to defend the result that you calculate. But if you cannot defend it, then you will in trouble. So you must, in the methodology part, explain how you validate your theoretical or computational results. Sometimes you want to also include the sensitivity analysis to demonstrate the robustness of your methodology, meaning that you have these calculations. So you expect that when you perturb the system a little bit, your result will change only a little bit. If you perturb it a lot, then you see change a lot. So that is a very simple way of checking the sensitivity. That is, you include some noise, you expect some noise as a result. If you change and perturb it a lot, you expect the result will be messed up. So this is a very simple way to check the sensitivity. So for example, if you come up with the result and then you purposely mess up the input, you make a lot of noise in the input, yet the result of your output remains the same. So that sometimes would signify or signal some error, because we expect that a little bit of error in the perturbation, a little bit of perturbation in the input would cause small perturbation. Large perturbation would cause a large change in the output. But if you do a lot of major changes in the input, yet the output still remain the same, then you know that something is not right, right? So this is one way to demonstrate the robustness of your methodology. Okay. And usually the method will not be very powerful. You have to also explain the limitations during the development of your methodology. For example, your methodology is only applied to geometry which is spherical. And if it's deviate, if your system is deviate from the spherical symmetry, then the calculation will not be accurate anymore. So this methodology cannot be applied to a shape that is too far away or deviate away too much from the geometry. Okay, for example, if you're doing a machine learning project, then you must express that that your project of this machine learning only applies in certain scenario, but not in other scenario. So this also has to be explained in your methodology section. Okay, so finally, in the methodology section, sometimes things could be very complicated. Like for example, in some of my projects that I offer, the procedure of doing the calculation is so lengthy. You have 1, 2, 3, 4, 5 until 10 pages. of descriptions how you perform the calculation. And people who read this very lengthy methodology section would be very confused and will tired as well. So usually you want to provide a small sections at the end of your methodology chapter, a summary that summarize the key steps in your methodology. Okay, so this is just an example. So imagine this is step 1, 2, 3, 4, 5 until 10. But when I write this in the chapters of the methodology, it takes up in about 20 pages or 15 pages, very lengthy, very complicated. But this final summary will help people to have an idea what have been actually carried out in the process of the methodology. So this is an example that says, in summary, the sequence of obtaining the final contact angle and its standard deviation proceed as follows, blah, 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 1 until 10. So this is a good idea of summarizing your methodology chapter. After you have finished the methodology section, then what you do in your actual calculation is that you would deploy your methodology in your project and then do some calculations, and finally you get some results. So this result has to be presented and also has to be discussed in the chapter called results and discussion chapter. So these are all the things that you have to show in this chapter. You have to clearly present your theoretical or computational results. So these are the results that you need to present, not the theoretical method, but the results. And then for this purpose, you usually have to deploy or employ visual aids, such as graph tables to enhance the clarity. And in this manner, people, like especially undergraduate students, they are not as experienced, because your calculations in your project, you may have a lot of data, and people sometimes feel very confused of how to make a good presentation of their data. You can group your data into group A, B, C, or group into 1, 2, 3, 4. And then people would mix up, do not know the best way to present the data in the most clear manner. So in this case, you would have to sit down and think very carefully. How are you going to organize the results and present it in a way that is clear, simple, and understandable to any reader? To this end, usually you need to organize your data in the forms of graph, a properly arranged graph that can make comparison, for example. And then you have to systematically organize and present the graph and compare it with the objective that you have outlined in your methodology. And sometimes it will be very helpful to present your data in a simulations. For those who have done simulation, you have to, it would be good, not to say you have to, but it is encouraged to also include simulations or link of the simulations in a soft copy of your report. So these are the example of the presentations of in calculated data. So here is a result that is calculated for a 2D case that is curved in surface, and the right hand side here is the result of the calculation for the molecular dynamic simulations that measure the angles, the contact angle for a droplet on a flat surface. So here is putting the two graphs together so that you can compare the angle measured for the contact angles where the surface is a curved one. So this is a surface that is curved. This is also a curved surface that is curved, but the result of the contact angle is calculated at different Lennard-Jones length. So here is also calculated with the 3 different Lennard-Jones length, but the surface is flat as compared to the graph on the left. So here you see that the graph is plotted side by side so that you can compare the results obtained for the one with a curvature surface and the one that has a flat surface. So by doing this kind of presentation, you can compare directly, and that is a good idea of making people understand the difference between the result for 2 types of surfaces. So this is just an example of making comparison in presenting your graph in the data form. And also in this case, not only you include the points on the graph, you also include some graphical visualizations of the simulation so that people and look at it, people know that this is for a curved surface, this is for a flat surface. So here you can make use of both the graph and the pictures for the data point to be presented on the same slides, so that that would be more effective in delivering the results that you want to compare and convey. This is another example of reporting your results. So here, people are doing some simulations to calculate the curve produced from literature and the one that is produced from the calculation that he done. So this is the result that I obtained from Gore. So he did a molecular dynamics simulations to simulate the curve for different types of atoms. Say this is an atom of neon, this is atom of argon, atom of krypton, atom of xenon. Then the red color one is the one that is calculated by him, and the dotted one is obtained from the literature. So this is a very good example where you present your findings in this kind of graph so that you can compare the theoretical calculations from yours and the one that is calculated by the literature on the same graph. Then you see that the result is actually quite nice. The result calculated with compare well with the one for the literature, and then you can also see that the result is also quite nice for different types of atom. So the idea here is that same graph, it compactly packed in a lot of useful informations that is efficient. Okay, so you can compare and see, understand the results just by looking at one simple graph, instead of letting your results scattered in many different graphs and make the comparisons or comprehensions or to understand your result become difficult. Okay, so try to learn how to present your results in the most efficient way using graphical representations. This is another example where you can represent your findings in a very graphical form. For example, this is a results that is calculated for different types of atom. Then what people do is that people compare the findings here, experimental values and the literature values. So this is the one that's calculated from his work. Then you can compare this with this. So this is usually done in a theoretical calculations or computer simulation calculation, where the result you calculate is compared directly with the one calculated from the literature review. So here he mentioned where the literature review comes from. I mean, where the values come from. These are taken from the literature review. So this is just another example where you present compactly your findings in a well planned tabular format. Okay, so this is just another example. If you have a simulations, you can actually include them into the thesis. But your thesis in the hard copy would be difficult. You can't really do these simulations in the hard copy, but you can always do this in the soft copy. Either you embed the simulation video in your PDF or in your Word. Probably you can't, but you can always include a link. You usually, for example, upload the result of the simulation into some online resource, say the OneDrive or in somewhere online. Then you create a link to the soft copy. So people who read your data, when you press this, then this video actually deliver much more information than the graphical form. So this is another way to present your data. Now, once the data is presented correctly, you have to analyze it and interpret it. So you have to conduct a detailed analysis of the result. And then you also have to analyze your result within the context of the theoretical framework or computational model, demonstrating the connection between the findings and the theory. And then you discuss any expected outcome. Now, here I highlight the in yellow color highlight. Then it says you have to analyze your numerical finding or your theoretical finding and make contact with the theoretical framework or computational models. You cannot just simply report your number. So these are the number I got. Then you just say this is what I get without explaining from the theoretical point of view the significance or the inference of this theoretical result with respect to your theory. Now, if you do not provide any interpretation based on theory for your theoretical finding, it amounts to saying that you don't understand how to make contact. So I think last time we have a undergraduate project competition in Xiamen University not long ago. Many USM students participated in the project, and many of them got shot down by the judge because they do not know how to interpret the number. Say, for example, they measure a lot of data. They get a lot of expensive data using all sorts of equipment. They just chart it, plot it, and say, this is what I got. But they never make contact for the data with their theory, and they do not know how to interpret the physics that is behind this data. So that is very bad. Okay, so you always have to analyze the results of your finding and compare it with the theoretical significance, or have to explain the significance of your finding. Okay, I think our students are very weak in this aspect. They just know how to get the number, but do not know how to interpret it correctly by combining it with the insight in the theory. Okay, so then finally, these are the things that should be mentioned in your data analysis. You should mention and acknowledge the limitations of your theoretical or computational approach. Then you have to also summarize the insight gain and the significance of your findings. And then you have to make a conclusion for these findings. So by following all these comprehensive guidelines, not only you can deliver the results of your project correctly to the readers, at the same time also the interpretations or the discussions of the result in your report also reflect how much you understand. This is what I always say to students in the Viva. If you understand a lot about your result, you'll be able to explain them. If you know nothing about how to interpret them, you do not know how to make contact between the findings of the result and the theory, then you will say nothing about the number. You just present the number as it is. So a presentation or discussions or the interpretations in the discussions of your finding reflect your understandings. Okay. If you know a lot, then you understand a lot. If not, then I mean, if you know a lot, then you will be able to explain. If you know nothing, then you just keep quiet. Then people would thought that you know nothing. Okay. So that's why I'm just saying, don't just present the data or the result in isolation. If you do that, it means you do not know the physics behind it. Right? People would talk bad about you because having only numbers in your finding would not be sufficient for a final year project. You have to interpret them correctly from the viewpoint of theory or from the viewpoint of computational modeling. Okay. Then the last chapter will be on conclusion and future work, which is kind of simple. Just write down your conclusion. This is a simple sample conclusion that I get from one of the final year project by Yong-Sing. So it's compactly summarized its finding, and it's very well written. Then in the chapters, you also write to mention part on the future research. So these are the things that you could mention in your future research. For example, addressing the limitations and how you can generalize your calculation beyond the limitations, and explore avenue, and how will you refine your methodology, and how to expand the scope, and probably mention about possible collaborative opportunity with other research group who is also doing similar project. So these are all the details, all the possible content that would go into the subsections of future research. Now, in your project report, you also may have an appendix. So these are the part where you keep it as an section to slot in materials that are too boring or too much to be included in the main text. So it serves as a repository for additional materials. But in order to prepare an appendix section, you need to follow these guidelines. That is, you must make sure that all your materials in the appendix are labeled correctly and organized neatly. And if you have any additional data or graph or any very complicated derivations of equations, you may also put them in the appendix. However, you must always remember to reference them appropriately in the main text. You cannot say I have an appendix A, but then if you look at the main text, you have nowhere to find where you refer to appendix A, right? So if you have appendix A, you always say, okay, in the main text, the derivation of this formula, number 3, is to be found in appendix A, so that people will go back and go to the back to check that, oh yeah, appendix A contain all the details that has been skipped when you derive these equations, okay? And sometimes also, if you have a lot of code algorithm, you also can put that code in the end of the appendix, okay? And sometimes, like in my project that I offer, the code not only is in a form, or it sometimes is not really feasible to have the code in hard copy form. You have a lot of codes not stored in electronic form, and usually we would put that code in an online repository, such as in the GitHub, so that you create a link to this online storage in the appendix as well, okay? So these are the best practice when you prepare for your appendixes. You must have cross-referencing, you have to maintain proper order and numbering and things like that. Okay, so then last part in your project report will be on bibliography. You have to maintain a list of bibliography, and then you have to provide all the informations of your citation. The bibliography here refers to the citation or references. Okay, so you have to first of all make sure that you make a consistency choice, or a consistent choice of your citation style. There are many different types of citation style, but personally, I would recommend to use Harvard style, because when you use Harvard style, you don't need to include the referencing number. You only list the list or items of bibliography according to alphabetical order. So that actually could help a lot when you prepare your thesis, okay? And of course, if there's a DOI, you include the DOI in the reference. And then also make sure that this is very important these days. Make sure that all the bibliography that you include are all correct. Because if you are using ChatGPT to prepare your references, very, very often the paper that is suggested by ChatGPT are all make up. You know, the ChatGPT hallucinated this paper which does not exist. So if you include that, then you will never find that paper if you do not check correctly whether the paper suggested by ChatGPT is indeed exists or not. Okay, so these are the practices which is very could be very cumbersome when you are preparing the list of bibliography or references. Sometimes you may have to say end up like 25 items of bibliography, sometimes you may end up 100 bibliography. So to include this bibliography is a process that could be difficult if you do not know the right way to do it. So the first thing I want to recommend is that you should make use of Google Scholar. Making use of Google Scholar allows you to obtain the bibliography item quite easily. So for example, let me show you here, Google Scholar, yeah. So you go to Google Scholar, you simply type something, try to find someone's paper. For example, say T.L. Yun, my own paper. Okay, so when I type this, then I can find my paper here. So I simply type this paper. So this is my paper. And then this paper, I want to cite this. Now, how do I cite this paper? There are two ways you cite this paper. Either you click on here and then you export the citation to a text and download this in your laptop. Then you open it. Then you cut and paste this. These are the bibliography items that is kept in the form of an text file, right? So this is a very cumbersome way of keeping the references. The other easier way is just to use Google Scholar itself. So here, Google Scholar, say for example, has this citation. You just click on this, then this is the citation. You can just cut and paste. That would allows you to keep an APA format citation or MLA format citations. Sometimes you want to keep a database of the citation for yourself. So that is also possible, but it will be kind of difficult if you do not know correctly. So what people do is people usually use Mendeley. It's kind of online software or EndNote to help curate list of your bibliography. But unfortunately, I do not know how to use it. I heard that you have to pay to use it. Last time USM used to subscribe to EndNote, but then I heard that they already not paying it anymore. So you may not be able to use EndNote or Mendeley online anymore. So what we do is, for example, I'll use this method. I use LaTeX and BibTeX and GetRef as my own way to maintain or curate my own bibliography references. And this could be kind of like technically not so trivial. We have to learn how to do LaTeX, and you have to learn how to do BibTeX, and then keep a list of all the database or list of all these bibliography items in your database, and then you cite it using LaTeX. But usually you can't do this if you are using the Word to prepare your report. And most likely people are using Word to prepare their report. So in that case, maintaining a database without the EndNotes, but using the Word to prepare your report sometimes could be a pain, very difficult and very cumbersome. But if you prepare your report using LaTeX, which is different way of preparing a report, which is not based on Word, then somehow the maintenance of the bibliography items becomes slightly easier. So I'm not going to go into this detail. Last time we used to have a workshop and teach people how to use LaTeX and maintain their own bibliography item. Okay, so we are almost at the end of the session. The last thing I want to tell you is that you are lucky because now you have ChatGPT. You can use ChatGPT to help you a lot with your preparations for your report. One of the things you can use for ChatGPT is to convert the format of the bibliography item. So you have many different formats, right? You could have, say, MLA format, you have APA format, Harvard format, Chicago format, and you have to make sure that all the format in your bibliography item is consistent. If you use Chicago, then you have to be Chicago. If you are using Harvard, you have to be Harvard. But sometimes when you download your bibliography item, the format of the bibliography item may mix up. Then you can ask ChatGPT to to do this for you. For example, we say, okay, please convert the following bibliography item from APA format to Howard format. Then within a split second, ChatGPT will do it for you. So ChatGPT is very useful. You can use it. I use it a lot to help me to prepare bibliography item that is kept in a different format. And then, of course, it can also be used to help me to prepare my text. So I prepare some text, then I cut and paste into the ChatGPT, and then it will help me to rephrase all the English for me. So that is all I want to say. I took already almost like 1 hour and 15 minutes to complete all these items on how to prepare your project report. I'll stop here for a while, and I would happy to answer any questions